Okay. Is it time? Yes, it's time. Alrighty, back to doing some game engine work. It's a little bit warm today, so we'll see how long I can go without needing to stop and drink a lot of water. Yeah, so last night, let me rebuild. Last night, we got to working on, or was it last night, or was it the day before? I don't know, it was yesterday or the day before yesterday. Yesterday we were getting all of the machinery in place for being able to close and reload projects. That means unlinking and relinking the DLL. And that was mostly done. There was a little bug that I didn't wind up resolving, but I identified what was causing it after the stream. So during the stream, I had identified that when I go to close the project and it closes the project out, that the debugger was saying that we got game systems cleanup call being made, which is correct. We are cleaning up the running game systems, but I didn't see a unloaded testgame.dll, and I identified what the problem was. The problem is this. I had forgotten that the game was running a test state that was utilizing a hot constant. So I'll just quickly demonstrate that. So if I go to run the game through the launcher, meaning that we are playing the game as a DLL module in the view here, and we got a simple state that shows some text and some sprites. We can move the camera around a little bit. I had forgotten that I was using a hot constant for the position of the text on the X. I don't remember why I was doing this, but basically the idea is that you change the value in the code, you hit save, and then it updates. So it shifted over by 1 world unit, or if I set it to 5, all of a sudden it's over there. And that's great. That's working fine, except when we go to try and unload the module. So if we go back to the editor and we run and we have the editor open, it has automatically loaded the test game project, but I had forgotten that we do actually have game code running in here, and a consequence of that is that even though the test state itself isn't running, this is not like the state code that we were just playing with isn't running right now. The hot constant is still valid, so I can still change this value, hit Control S, and we'll see in the console it says hot constants reloading file teststate.cpp, and successfully reloaded that value. So what's happened there is that hot constants works by running a background thread. So the idea is that whenever you have a constant value that is a matter of taste that you want to tweak at runtime, you would use, instead of saying constant float name and whatever, you would say HC, use the hot constant macro, the type and then the name, and then you set to that, and then you just use it like normal. So I'm using test position X as a regular float value down here. And what happens is that this macro automatically starts a background thread. It calls this static function called register hot const. And if we go deep enough into the code, we get to this code add watch, where we tell it where the file of the source code is, and it actually creates a STD thread somewhere here. Here, our watch threads in place back, and we construct a thread that actually watches for changes on the source file. And so, for some reason, and this is something that I'll address separately from my game engine, for some reason, when the cleanup code is called for my hot constants library, it's not correctly canceling the thread. So when we go to go file close project, we see game says cleanup, but because there's still a background thread running from hot constants, there's still a reference to the DLL. And so if we go to, it's in my downloads folder, I think, process explorer, this guy, run it, there we go, and find enterprise in this list. Here it is, enterprise.exe. You can see that testgame.dll is still loaded. So to confirm that that's the whole problem, basically I just come back into the state itself, comment out the hot constant part, and switch it to being a regular float constant. And then when we go to run it, oh wait, I have to recompile all because this is a optional module. Let me recompile that real quick. Come on. There we go. Oh, what's taking so long? There we go. So when we go to reload now, everything seems to work. And then when we go to file, close project, we go to the debug console, we see that it actually is unloading the module. Because now the hot constant macro is not creating a thread. Anyway, that was kind of a diversion, but I talked about this problem at the end of the last stream and I wanted to bring it up again if anybody watches these. All right. So back to where we were. What's that? So we've now got to the point where it's the game project is able to load and reload without breaking anything. So I think, unless I'm forgetting something, I think we're probably due to start working on some play and editor stuff, or at least the ability to load and view scene files, which is kind of exciting. Yeah, that's probably good there. And let's set up play and editor. There was one last thing that I had noticed and I was wondering about. I'm probably going to want to take care of that first. I had noticed that sometime between the start of the last stream and the end of it, I lost the ability to use mouse input, which I'm a little confused about because it's the same API is being used to do the keyboard input as the mouse input, so I must have accidentally deleted something somewhere. So we got load context file test input.ini. If we take a look at the test input file, okay, so this is the input that I've got for simple debugging stuff. We've got an next action on escape, and the toggle action on tab. Is tab working? Yeah, tab is working. Right now I have it toggling between which shader it's using on the text. The movement is obviously working. Speed boost. Am I using speed boost? Well, that's interesting. Speed boost isn't working. The idea that you hold down shift and you go faster, that's not working. That's confusing. So actually there must be some residual problem that we should follow up on. And there's sure to be more in the future that I'll notice as I continue to work. Okay, so shift isn't working. The looking and the mouse click is not working. Let's try a gamepad. Maybe I'm curious to know whether these same controls, speed boost and the look X and look Y. Well, actually, hang on a second. Yeah, speed boost is available on the gamepad. The look X and look Y are different for mouse input. Let me grab a controller real quick. All right, I'm back. And log her in. Get myself a Xbox One gamepad. And let's run the test game real quick. All right, so it's moving to... Okay, looking is working on the Xbox controller. And which control was it for the speed boost? Interesting. So right trigger is not doing anything on the gamepad either. So this tells me that something is up with these specific bindings that's causing them to not load correctly. Huh. Oh, I think I've got some idea about why that might be. Oh, that's interesting. I pressed the back button to quit, and we got this unhandled exception. What's the exception? So we got game exception thrown. Okay, let's go to the call stack. Here we go. An issue. Okay, so this probably relates to the problem that we were dealing with. I was able to press escape to quit before, so something specifically about processing the Xbox controller's binding. Okay. So currently action callbacks is 0 in size. Which is interesting. Let me try reproducing that again. So first I'm just using the keyboard. So keyboard escape works. And then the back, or the, I don't know what they call it, the back button on the Xbox One controller. That should be doing the same thing as the escape key, but it's not. So that's telling me that some of the action callbacks are not correct. So we are in, okay, process run, while time process fix update. All right, so this is marking the next line to execute. So actually we are in the middle of input update. We have invoked process context. So we got, this is the input context that we are processing. Input contexts are like an instance of mapped input. So if you have a system that needs input, or if you have a script that needs input, or a game state that needs input, it can create its own input context and receive input filtered depending on the situation that you're using it in. So you can, the most common case would be that you have an input context that uses like one form of input, and then if another context is put on top of the context stack that needs that input, it can block that input from being propagated to the lower context. So these are instanced. We've got keyboard escape tab, options menu. Right, so this is the context for, yeah, this is going to be the context for the test game state. And then It looks like the issue is coming from... Yeah, I'm not getting enough information from this point of view. Action callbacks is 0, but I don't know why that would. Let me stop and set a breakpoint for this for loop and see if I can catch it earlier on. Okay, so let me press the back button. So this is the breakpoint being called, not the error. So this is the first detection of an input action from the gamepad. In this case, we are dealing with the back button. Okay, so currently we have size 1. So we get the callback. We set to the active state to. So this has to do with input code in the state machine being state aware. So it has to know which state it's in. So what we do is we mark the active state to be the one that's responding to input, and then we go into its callback. And at this point, the action callbacks is size 0. So let's head back to that callback, which for some reason I wasn't able to step into. That would be, it should be a lambda, if I'm remembering right. Input. So we load the context file, we bind the context, so this actually gives us this context. We got exit and toggle. So exit invokes state manager and state. So I set a breakpoint in end state. Okay, so now we are inside of end state in response to pressing the quit button from the Xbox controller. So we've got a strong reference to the state. States are passed around by STD shared pointer. Okay, and this is where we do state stack relinking. The state stack is linked list. So it's actually called state list and not state stack anymore. So at the very end of this, we've got no states. And then we can step out. Okay, and now we're back out to the input. That seems normal. I'm going to do this slightly differently. With those same breakpoints set, I'm going to use the escape key. Oh, that's interesting. So when I'm using the escape key instead of the Xbox back button, it goes straight to end state. Oh, right, because this breakpoint is for Xbox gamepads specifically. I'll leave that there and let me find the equivalent keyboard mouse action. That would be this one. Okay. Got it. So let me try that again. Escape. Okay, so yeah, we still have the size 1 on the action callbacks. Okay. And then action callbacks is size 0 at the end of this. If action callbacks dot count. Oh, that's, oh, okay. All right. I think I know what this is. Yep. There it is. So actually, this has nothing to do with any of the work we were doing yesterday. Basically, this is a bug that I guess I hadn't completely squashed. There was an issue before where if you press the if you respond to a input action with closing a state, then it would still try to iterate through memory used by that state. That's actually external to this loop. So yeah, we call the break on it. So action callbacks.count context. If there's no action callbacks after responding to the state, then we break. And I just didn't have that in place for the Xbox controller yet. So that should be a fix. Let me clear those breakpoints, rebuild all. And we should be back in business, at least working back on the first issue. I had to underclock my PC recently because it was overheating, and my fans were just not doing it. So I feel like it's running a little bit slower, but that could just be me. All right, so here we are, we're back. I pressed the back button on the gamepad and it's not crashing anymore, so that's great. That was one thing. However, the issue with the mouse input not working and the shift key and the right trigger specifically not working, yet everything else still works. I have an idea about what might be going wrong there. Let me close out of all the things we just opened. And let's go back to the input INI. So what I think may be happening is that the controls that are functioning correctly are the ones that have multiple bindings for them. So for example, the exit and the toggle buttons have a keyboard and mouse mapping, but they also have a Xbox mapping. In the case of looking and enable mouse look, these are keyboard mouse specific input mappings, so they are only listed in this file once. The one hole in that theory, though, is that look X and look Y for a gamepad seem to be working, and they are only listed once as well. Yeah, so something must be going wrong regarding the cleanup code is my best bet, because that's where we were doing modifications. Let me change this to the test game project. So this is the standalone shipping game. Okay, and it actually has the same problem, which is interesting. And the same thing on the... Yeah, the right trigger is not increasing speed. I'm gonna do a quick proofreading of the test state, even though we didn't really make any changes here. So we bind to exit, we bind toggle. And then we go to that's the draw call. So in the draw call, we clear the viewport, we set depth testing, set the blend mode. We set the camera pitch on roll based on input get axis, enable look mouse, times look Y mouse, and time game delta, and look speed. What's look speed? Look speed is in the header. It's a 3.0f. We then have the polling for contacts, look X and look Y for the gamepad, which frankly looks very similar. Let me set a breakpoint on these and inspect the return values. Okay, so this is look Y mouse is what we're inspecting. I'll eventually be getting around to doing some of the more developer friendly aspects of the editor and the code, like logging. Right now, it's really kind of a chore to dehash a hash name. I have to manually type in hash name to string in the watch window. I'll come back to that, but this is look Y mouse. Access values dot count. Okay, so access values. We check whether we're in the fixed time step. We look for the associated context and access name elements. Okay, so let's inspect that value. No operator matches these operands. Sure they do. Okay, well, let me just substitute these values then. Access values. We are not in the fixed time step. Context is this memory address. The access name. Maybe it's maybe I have to actually do a 0 here. No? Huh. That's weird. For some reason, the watch window is not playing nice with this arrangement. The access values that I have stored, basically these are the converted axes for all input. You just tell it whether you're in the fixed context or the dynamic context, meaning that you have a slightly different input for mouse in particular if you're in a fixed frame versus a rendered frame, a dynamic frame. I just want to see what's in there. So what I just did is I stepped out, and hopefully I can just see the return value in this window. Okay, yeah, input get access return 0, and that should not be the case because it's mouse movement. It's going to be non-zero. So something going wrong with the setup code, I guess. Let's go to back in the test state. We're going to go to test data init, and then I'm going to go into the process of binding the context. Because this call here, input bind context, test context, and then I tell it the stream ID and the blocking level. This is where the input action list is created. There we go. Bind context. Context registry dot count. I may just want to switch over to Visual Studio for a minute and debug this there, because I'm getting really annoyed that I can't just mouse over and inspect these values. Visual Studio has a much better C++ debugging situation. Okay, so for every... Okay, so right now there's a single context in the context registry. Yeah, so I'm going to actually go ahead and do that. I'm going to leave the space of Visual Studio Code, and I'll just set this up with Visual Studio real quick. So delete my build folder, delete the data folder. All right, and then I'll use make, or I guess I would do make dir build, build, make, then G is visual. Oh, I always forget the exact string that it's supposed to be. They make so they make the string for Visual Studio like stupid. Like you have to list the numbered version as well as the year, and I don't know why they thought that was a good idea. Oh, but I forgot to do. So we're building in this folder. Building the source folder above. We're using Visual Studio 2019 as the generator. Okay. I normally just use CMake tools in Visual Studio Code for this, but Got a fly landed on my glasses. But the debugging tools there are just not hacking it for this particular problem. Okay, what do we got? CMake error. Engine slash source directory vendor hot constants does not contain a CMake lists. That txt file. Yeah, it does. Oh, okay, that's annoying. Okay, it reverted. Hang on. Yeah. It reverted the submodule here to the one that's actually checked into the source. I need to bring it back. Source control, please. All right, and wouldn't mind. What's all this? History. Yeah, right now we have a detached submodule. Get check out master. Get fetch status. Okay, the CMake lists is back. Okay. I'm a little bit worried that I might have to set up the CMake list file for that one library that we're using for opening the file open menu. Editor, vendor, native file dialog. Okay, still got it, CMake lists. Okay. And we don't have any errors here, so we should be good. So back to what we were doing, go to the build folder, and now we've got a Visual Studio solution. Cool. All right, now we got Visual Studio open. We were working with not the editor, but the launcher. So I'll say set a startup project, and let me confirm real quick that the debugger is specifying, yeah, so it's got -- sandbox and it's got -p for project, and it's specifying the path to the test game EP project file. So that should launch the game. Oh, but I actually have to build the entire solution instead of just, hang on a second. My habit is to press F5 because it'll automatically rebuild anything necessary for the specific target. But I actually need to do Control-Shift-B here because in the case of the launcher, the game project is not an explicit dependency. It's actually not a dependency at all of the launcher. So the launcher has to be built after you build the game. Or you should build the game, then run the launcher. So this may take a minute because I had to clear out the old Ninja Clang build system to be able to work in Visual Studio like this. Is this using, let me check. I'm not sure offhand whether this is using MSVC or Clang. I don't think that I have like a default in the CMake lists or anything like that. General. Yeah, this is using MSPC. Okay. Okay. This may take a minute. We're recompiling the whole engine twice with the editor and the launcher and the game and stuff. I'm going to take a quick break. I'll be right back. That would be this key command. Okay, yeah. I'm back. Yeah, so that's all rebuilt. F5. Okay, so we got the game state working again. Same issue as we had with Clang and the other, which is, you know, expected. Yeah, the right stick works for some reason, but not anything else. Cool, so now we are in a better debugging situation. So let's go to the test game. And we'll hop into test state.cpp. And hopefully this will go a bit smoother. So I'll set a breakpoint here, being sure to move my mouse while it's getting started. Here we go. So cam pitch plus equals get access look Y mouse. So let me step over that and confirm. Yeah, cam pitch is still equal to 0, so that just returned 0. It really should be non-zero. And then we got get access context. I'll step in this time, but not into that, into here. Float time, game delta. What is this? Oh, that's here we go. Input get access. So we got the input context, and we've got the access name. Okay, that's interesting. I'm taking a look at the address of the context handle. Hang on, let me step over. Oh, it just hadn't been passed into this stack frame yet. Okay, so we got the context, we got the access name, which should be, if I copy that down into the watch window and I do patch name to string to be equal to, oh, this is enable look mouse. Okay, that's interesting. Okay, that's still something that we should have an obvious return value for. So here we are at the axis stack values, and this is why I changed to Visual Studio, because I can just mouse over stuff now and inspect the values. So we are currently not in a fixed time step, right? This is, yeah, false. So we are currently in, yeah. And then let's get back to, oops. Here we go. If we inspect axis values for false, and then into the only context we have registered, we have, here we go. Here, these are all the action bindings. So they're all keyed to the hash name of the sorry, not action, axes. So these are all keyed to the hash name of the axis, which is a little bit annoying, but the first thing I'm going to do is I'm going to count 1, 2, 3, or go up one level. There's 9 keys in here. So if we go to the INI file in question, that would be it was test input .ini. Oh yeah, right, it's not in here. Data files like that are not part of the Visual Studio solution, so I'll just click and drag it. Okay, here we go. So to review, we've got 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 10. Okay, wait. Oh right, these are doubled up. Okay, so 1, 2, 3, 4. So that's 1, 2, 3, 4, 5, 6, 7. These are all in common with above. 8, 9. Okay, so there are 9 axes, so that tells us that the context at least has bindings for all the axes. They're all set to 0 right now. So I stepped out and back in, and now I'm taking a look at the get access call for what should be, let me get that. What should be the actual mouse access. Oh, that's interesting. The hash name is empty here. Wait, step over. Oh, I keep forgetting that you have to actually step over once you're in the function to actually get the values from stack frame. Yeah, so it's a little small to read on Twitch, I'm sure, but this is lookx mouse is what the access name we're looking at is. And if we step over, take a look at the access values. None of these should be 0, I don't think. So the contexts actually do have the actions. They're just not getting updated with the correct data. So let's go to input.cbp. And we're going to go to update. So this is actually the update core call for the input system in general. This is where we actually will fill the structures that we use to provide input to all the input contexts. So the issue must be arising from something in here. But I don't see how it could be, because this section of code has not really been touched for a long time. It's kind of tried and true at this point. We don't see any colored bars on the left to indicate that this differs from what's in source control. Oh, but you know what? I just had a thought. I think there were... So one of the things that we worked on during the last stream was to get the events system to flush and set back up again properly. I have a sneaking suspicion okay, so we do have an events subscription in here for raw input. Basically the handle platform events call we actually takes and interprets raw input events and converts them into data that we put into the input. Perhaps there's something going wrong with the raw input event itself. Maybe I'm gonna set a breakpoint here just as a hunch. Okay, so when I went to press the ASWD keys, handle platform events was invoked, and that was because the input system fired off an event containing the raw input structure from the Win32 API. So we've unpacked that here using events unpack. And if we take a look at the data section, we've got mouse, keyboard, and HID, like I think it's like human input device, I forget. But basically we are using it to get the mouse and keyboard info. Stepping over real quick. And basically we have a series of if statements that go through and compare the V key virtual key codes to certain ranges to identify which key we are working with. So at the end here, key code equals 65, which tells us, here we go. So the KBM buffer is being set correctly. We're going to click continue and just return to the state. Okay, so when I go to click and drag the mouse here, nothing is happening. I have a breakpoint set to respond to all raw input events. So there must be something going on where the event is not being fired from the raw input API for some reason. That is interesting. If I press the left shift key though, the left shift key is, so the left shift key is engaging the handle platform events. Which is confusing because if there's a failure to fire off the Win32 raw input event, then that's not our only problem, because the left shift key is also not working, but we're getting a Win32 event for it. We identified the control as 117, which is, I should be seeing KB L shift here. Is that? I'll just quickly check it. Oh, it's control ID, not control IDs. Oops. There we go. Yeah, the L shift is 117, so it's correctly identifying the key. Let me stop that real quick. Oh gosh. Okay. All right. So the shift key doesn't come into this. Okay, that makes sense. I think I've figured something out. So there's multiple things going on here. The first is that there was a problem with my testing. I was presuming that the shift key was not working for the same reason that the mouse was not working, but that doesn't seem to be the case. We have exit toggle, and then there's an axis that we're supposed to be polling for movement. If we go back to test input API, or test input.ini, we've got the speed boost axis, and it's simply not in use. Okay, so let me hook that up real quick. So we'll go back to where it says movement speed. Here. So move speed is the speed set by a constant right now, just for demonstration purposes. If we were to do input get axis for the context, the IntelliSense is not being very helpful at the moment, is it? I'll come back to that later. Input get axis for the context, and we'll use the hash name speed boost for the name, and then we multiply that with the movement vector, the right vector, and the up vector. Okay, let me rebuild and test that. Oh, whoops, and stop and turn off my breakpoint. Come on. Okay, and build that again, or run it again. Okay, yeah, now the shift key is working. So what's happening is that it's at 0 until I hold the shift key, because I forgot that I need to add 1 back to the code I just did. All right, so the shift key is actually functional, and that's presumably the same for the gamepad. So that limits the issue specifically to the raw mouse input. Okay, this has been taking a while, but finally getting somewhere. So I'm going to go ahead and quickly fix this. So we have the move move Y, move X, and move Z from the input context. Multiply it times the game delta time, which is the same thing as like time dot delta time in Unity. Move speed times, so move speed, it'll be moving at the move speed times 1 plus the speed boost, I think. Because the speed boost is how is that bound? Speed boost is a scale of 1, so it's while it's being held, we want it to be multiplied by 2. So let's go back to the state. So this, I'm just gonna quickly put that in parentheses, and it'll be 1 0.5 plus, put a closing parenthesis here. This is a little hacky looking code, but I'm basically not interested in, oh whoops, it's gonna bug me, but I keep forgetting that I have to rebuild the solution separately from launching the launcher for this code to take place. Okay, so now here we are. We got ASWD moving, and then we hold down Shift, and it goes twice as fast, like that. And if I try the right trigger on the gamepad, yeah, the right trigger will speed up as well. But I can because the trigger is a analog control, I can actually slowly ramp up and slowly ramp down speed. Okay, and actually, let me launch that again. Yeah, okay. It seems like every control works on the gamepad, so I think I'm right on the money now for what needs to be done. So we need to figure out why the raw input value is not being sent from the mouse anymore. So we're looking at the Win32 API stuff. We've got dispatch for controller disconnect on the gamepad. We've got dispatch for the controller wake event. And is that really it? Hang on. Oh, right, that's it, because this is the reason why we're using the event system in the first place. The raw input event is kind of tightly coupled to the Win32 window API, or the window process API. So let's go to, I believe it was window Win32 for the engine. Okay, and then we got, here it is. Events dispatch, Win32 raw input. So this is where we normally dispatch that stuff. Mouse move events are specifically for identifying the position of the cursor on the screen, which is different from getting the raw delta of the mouse movement. Okay, so everything seems to be in order here. This is not a very complicated piece of code. We the raw input API is C style, so we've got a bunch of we basically just like allocate a block of memory, and then we pass it in as an out variable to get raw input data. And that gives us a structure which we can pass around, a raw input pointer structure. So something must be going wrong even before we get to this point. In the code that sets up the Win32 or the raw input stuff, we are failing to register mouse movement. Okay, I'm going to press F5. I've got the breakpoint set on the window procedure, and you can see as I move my mouse and click, it's not actually doing anything, but as soon as I press the keyboard, it will hit. So I'm gonna need to take a look at the docs for this. I'm gonna quickly change the title of this to be like bug hunting. I'm just realizing that this stream is very we've been going at this for an hour and we haven't gotten back to working on the editor yet, so right now we're bug hunting. So there'll be Win32 raw input YIME. So there's a call for register raw input devices. Okay, to receive WM input messages, an application must first register the raw input devices using register raw input devices. By default, an application does not receive. Yep. To receive device change messages, you must specify whatever flag. Let's go to an array of raw input device structures that represents the devices that supply raw input. So let's find this call in my code. Maybe that's done the entry point. Huh. Oh no, here it is. It's in when the it's in Enterprise Input Platform Init is where we got it. Okay, and all of this code seems to be the same as it was. Oh, hang on. I think I figured this out. There was a point before where, oh god, here it is. That's annoying. Okay, why is it? So, hang on, let me first fix the problem. And then confirm that it is working. Yeah, now it's working again. Okay, yeah, so now I'm left a little bit confused. Oh, so I don't actually see, hang on. Yeah, so I got a little flag here indicating that I made a change to this file. But I didn't see that in my, VS Code view. That change should have showed up as a git diff. Let me open this in VS Code real quick. So in VS Code, let's go to the source control tab, or view, or whatever it's called. And taking a look at the input win32.cpp. Oh, okay, yeah. All right, so what had happened was that for demonstration's sake, I had put in a ORD flag in here, and I forgot to take it out. So what I was looking at before was during the last stream, I was considering going ahead and unregistering all of the platform, all of the raw input calls, unregistering from the raw input API the request to receive mouse and keyboard messages. And I demonstrated that the way that you do that is by plugging in, like, you have to, like, in the usage flag specify I think it's like the first bit, like OX01, you have to set in this bit field, and then that gets you a cancellation of receiving those messages. So I put that in there, and then I didn't remove it, and wow, that's embarrassing. Okay, so oh, whoops, I'm on the VS Code side. Getting back to Visual Studio side. So now all the input's working correctly again. God, that's frustrating. Oh, that's interesting. I broke something when I tried to build from VS Code. All right, so here's what we'll do then. I'll close out of this. Build, cancel. Switch back to VS Code. God, that's embarrassing. It's always something stupid and simple. It can't ever be. It can't ever be some kind of revelatory experience where that's the trouble with bugs, is that it's always your fault. Okay, and I'm trying to delete the build folder, but it's not being released yet by Visual Studio. Okay, let me close out of all that. Okay, I'll just leave it and then go and reconfigure from VS Code and leave the remnants of the old build system. That's fine. Hot Constant's got Hot Constant's got moved back to the previous checkout. Let me go back to it. Source control, Hot Constant, and we will check out master. Okay. And then we'll try this again. There, figure. Cool. And now if we do F7 to build all, going through Clang again, and we are now recompiling with Ninja. Okay. That's gonna take a minute. Cool, so I think we're back on track finally. So, now that that's all done, we're going to be looking at play and editor stuff now. Which is going to be the real fun stuff. Basically actually doing stuff with the game module code. Because up until now, it was all about getting the game module to even, like getting the ability to open and close game projects was all that we were focused on. But now we can actually start like running game code in the editor, which is what this is all about. And to be honest, I'm not really sure where I want to start there, because there's a lot of different things. It means getting back into IM GUI code, and that's something that I have the barest understanding of how to do. So this will be fun. This will be a learning experience. I'm gonna go ahead and take another quick break. This is gonna take a little bit to recompile. Let's give it, I don't know, 4 or 5 minutes. Okay, back. How are we doing on the music? We're about 2/3 of the way through the playlist, maybe a little bit more. So, where did we leave off? Okay, so test state is working again. Got the shift key fixed, got the mouse fixed, got the gamepad all working again. And we fixed the crashing bug with the quitting from the gamepad. So let's take a look at what we got in source control, because we're going to need to commit some of this. All right. So I think for the first thing I'm gonna do, where is Hot Constants? Hot Constants had an update done to it to make it compatible with CMake, and I brought that in and started using it, and I hadn't actually committed it yet. So let me do that now. So we're, as a rule, we don't commit anything from test game except for what's strictly necessary to get it to run, because that's intended to be a place to test out whatever wacky code that we happen to be working on. So underneath the vendor, we've got hot constants. I'm gonna add that. So now we've added the update to hot constants to the staged stuff. I'm actually going to not commit native file dialog quite yet. Native file dialog, I'm not 100% sure if I want to keep it. It works pretty well, but not so well with IamGUI because it's a modal, and if you open up a modal from something that's not a WinProc message, then you're going to have a bad time. Let's start with hot constants. And then I also need to commit the changes to CMake lists that added it. Okay, so this file is the CMake lists for the engine library. We've added the subdirectory vendor hot constants. We've added the hot constants link to the dynamic and static versions of the library. We've added the hot constants reloading on for debug builds. So that way the mechanism only reloads if you save changes to a debug build. Which actually I should change that. I should add for dev builds as well. Because development builds are where you're going to do most of your work, and there'll be some optimizations in dev, but we still want to be able to do live value to a game. So that's something to modify. And so long as that all builds correctly. And it seems to be. Oh right, I deleted the data folder, so it forgot all of the window arrangement. We'll worry about getting all the layout to be looking nice later down the road. Cool, and then let's commit that. Given the number of things that had to go into making this work, I kind of worked for a while without committing anything, and that's bad. But scene manager init. Let's start with updated hot constants, and with one N re-implemented with CMake. Good. And then just reviewing all the things that we've added. File.cpp, so this is where we actually do the file open dialog in the editor. Scene editor. Let's focus on engine side things first. So what do we got here? We got extern string, project friendly name. Okay, that's important. We added a renderer 2D cleanup call. Did we actually do anything with the renderer 2D cleanup call? No, we didn't, actually, so I'm going to just undo that change real quick. Start change. Render 2D as a clamp call we don't need anymore. And then back in the test game module, I know that that's going to break the entry point here because we called renderer 2D cleanup. Which no longer exists. So let me F7 that and make sure that it still builds. Which it should. And I want to see this game module loaded. Please. Here. Game module load.cbp. Simple as balls, we just return whether his game module is loaded. His game module handle equals null. Yep, and this is where we get the project friendly name. Cool. Okay, so we'll keep all of these changes. Do I need time in here? What's time used for? Time set timescale. Okay. And unload game module. You know what? I think I am going to change that. What I did is I put I reset the timescale to 1 when we go to unload the game module from game module load the runtime or the runtime business. But I think that might not be the best place to do it. Now we are, as of last stream, we are discarding and recreating the entire engine runtime. So I think what I'm going to do instead of that, get rid of that and confirm that this compiles. Instead of doing the reset in this file, we'll just go into the time systems destructor or cleanup call and do it there. So we got time, init and cleanup. We got delete uniform buffer. And here's init. So we got platform init, and then we got time global UV, where we create the uniform buffer. I will just set the timescale 1 here as a part of init. Yeah, and for some reason I did this as a double, and then compared to a single precision float. It's been a long time since I've done a lot of this code. I've learned a lot of C++ since then, so I know that that's probably a mistake. But I'm not gonna bother. You know what? Yes, I am. I'm gonna change this to float. There's no reason to be doing double precision floating point scalar math in this case. Let's go to time.h. Change this to be, or not that. change the set time scale to accept a float value. That's interesting. I just went to search for where we actually use the scalar value, and I'm having a little bit of trouble finding it. I had assumed it was in here somewhere, in time.cpp. We got time, real time, game time, blah 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 blah. So we got time, real running time out. So it should be an update, I would think. Here we go. Previous system time in ticks, current system time in ticks. And we use a platform-specific tick getter. And we do seconds to ticks. We do all of this in double precision. And this, to be fair, probably should be in double precision. We use seconds to ticks in a few select cases. So if we are shipping... So if we are shipping a game, this is going to be hard-coded. We won't actually be converting from ticks to anything. We just do the math directly in ticks. Which is, just to be clear, when you get the time, the lowest level, highest fidelity counter from your computer processor, it measures it in an integer count that's ticks, that just keeps increasing. I believe it's from the time you turn your computer on or something. And that just keeps increasing forever, and then you compare that to the length of the tick in seconds. And I have a conversion function here that I use specifically because I wanted to use hot constants on this frame delta. You know what? This is not worth changing right now. Eventually I'm going to have to come back in here because I'm going to be re-implementing the way that I did my constant values. There's going to be like a project properties data file for each project that will be resource compiled into the binary, but that's a future Michael problem. Anyway, time.cpp now has set timescale in the correct place. And let me confirm that I didn't break something just now. I'm going to change from bug hunting to... I'll do that after we've wrapped up with commits. Good, and F5 and everything's still Midori. Alright, good. So back to where we were. That. I'm just going through these files one by one. So game module load cpp. We got rid of the time dependency here. Now we also have the dependency on scene manager and state manager, which I'm not clear on why we did that. I don't think we actually wound up using these. I'm gonna take those headers away real quick and rebuild. Okay, it seems to be building just fine without those headers. I must have put those header inclusions in preparation for doing something else, but it's something that I never did. Okay, and then most of these changes are just tab indents from when I put this all in a if block for the cell statement. I'm gonna change the music up. Gonna go ahead and do. There's not a lot of music that I know that will be safe on Twitch. I'll go ahead and do the newest sessions from League of Legends. It seemed to be like way higher energy than I wanted to during my stream last time, but I'll deal with it now. Okay. Okay, cool. This file is probably ready to go. So let's add it. Cool. And then in the platform-specific input files, I had to do a condition for init so that it wasn't reinitializing the lowest level input registration stuff. Yep, so those need to go in. And what do we got here? This is the regular input .cpp. Oh, this is, okay, that's important, but it's unrelated to what we're doing. So this is the bug fix from earlier this stream, where quitting the application from a gamepad was causing a crash. So that's important, but it's not related to the feature we're adding, so I'm going to save that for a separate commit. We are no longer using this reset input system call. We gave up on that idea pretty quick. We do need the input cleanup call though. So let me save that. Head to input.h. Remove the reset input system. We'll leave cleanup. Rebuilding again to confirm I didn't just break something. And then the cleanup call is part of what we're committing, but this is not. So I'm gonna have to do something a little janky with this file. I'll come back to it, but the idea is that I'll want to stage this file without this change. So I'll come back to input.cpp. Graphics. We had to do the is already initialized trick to avoid double initialization of the global vertex array object. And additionally, we needed to track the global VAO for rebinding, which up until now I hadn't been doing. And that's particularly important with IMGUI, because IMGUI may bind a different vertex array object while I'm trying to use the global one. So right now, all we're doing with it is we are binding it and keeping it. I need to actually go through, and I have a little to-do message here. I need to go and rebind this to prior draw calls. So that is, I need to actually add the binding of this protects array object to my engine draw code, which wasn't necessary until I started working on the editor. So I just didn't do it. So all of this code needs to go into my commit. So I'll go ahead and just add that. But something I'll need to do today before I forget after this commit is to actually go in and start getting the global VAO bound before rendering anything. Because otherwise, when we go to render the scene in the editor, we may find out we just have a blank black screen for no reason. Okay, events.cpp now has a cleanup call, and the cleanup call just clears the callback pointers. That's going in. I don't recall why we needed to friend the runtime class. So let's head to runtime.cpp and double check. I'm gonna leave this. I had an EP assert no reentry macro to prevent double initialization of the enterprise runtime, but now we are explicitly double initializing it. We're creating and then tearing it down. So I'll need to come back here and figure out something else. So I'll just leave the comment with the to-do on it. To-do move window init to launcher. Yeah, that's a wise call, but I'm not going to do that right now. And we added this block to runtime.cpp. Right, this is where we cached the default command line options. So when we're working in the editor, right, so when we're working in the editor or the launcher, we would normally specify on the command line whether we're going to be sandboxing and whether we're going to be running from a project file. In the case of the launcher, that's required. You have to be running from a project file. Whereas the editor, you can open it up with no project. And we had to store those command line options in the registry again after flushing it. And this is where we needed scene manager cleanup. Okay, so I'll come back to you. And oh, except for that wasn't what I was looking for. I was looking for okay, here it is. Events cleanup. So that's why we needed it. Runtime is actually invoking cleanup here. Right, that makes sense. So that and that are fine. Good. So let's commit this file. Okay, global VAO. Yeah, we actually needed to declare the static unsigned global VAO handle. Cool. And now input has a cleanup, which to review, all it does is unbinds the. Oh, hang on. Yeah, this code is not sufficient. So what we did is we unbound the default binding, the keyboard and mouse. We actually need to dump all bindings. Okay, hang on a moment. there's always something else, isn't there? Unbind controller. We pass in the controller ID. And then we tell the buffer that we are unassigning. Okay, so basically we're going to need to do this stuff directly. So let's copy and paste. I'm going to copy and paste this whole block of code. And we'll only keep the parts that we need. But I'm coming back down here to the input cleanup method. And now we are going to be clearing all of the flags for bindings. So the first is kbm buffer is assigned. In the case of the keyboard and mouse input buffer, we just have a bool associated with it. We have a whole vector of gamepad buffers that need to be assigned or marked as assigned. So in the case of them, yeah, we need to actually iterate through and delete them all. So kbm buffer.isAssigned is false. And kbm buffer always exists. It's a static member. The gamepad buffers, that's a vector of gamepad buffers. So I can actually just call gbuffer.clear, and that should delete all of them. Okay. Controllers less than gamepad buffer.size, blah, blah, blah. I feel like I'm overlooking something here. The thing that I'm confused about is that I'm not actually observing in my code the place that I initially identify when a X input controller is connected. And that matters because I don't want in the case of reloading a game module, I don't want to be flushing information that's still in use. So I need to actually track down where the gamepads are initialized, and then I need to ensure that I'm not breaking something by deleting these gamepad buffers. There's got to be a reference to the gamepad buffers in another file. Oh, okay. Yeah, I think I know where I'm getting stuck up. Okay. So actually, I don't want to be clearing these. What I was getting confused about was the idea that I wasn't actually able to track down where the gamepad buffer was getting allocated, so I wasn't sure if I cleared it in cleanup, whether it would be reallocated during runtime, and it won't be. And that's because at the moment we're only doing X input gamepads, and so that means that we are limited through 1, 2, 3, and 4, so I just allocate all 4 up front. So actually what I need to do is I need to go for I equals 0, I is less than gamepad buffer dot size, I plus plus, and then we will go into the gamepad buffer at index I dot assign stream equals dot s dot assign stream equals stream ID 0. I don't actually have to cast the 0 to a stream ID type. I'm just doing that for the sake of legibility. And stream ID 0 represents the null value. Okay. Good. I think that's that. Then what else happens here? We go through stream bindings. It's a vector of control IDs. So stream bindings as a okay. I think there actually might be a lot that we skipped over for now. We actually have to reset a surprising amount of stuff. So we have to we have these 2 vectors are indexed by stream ID. So they contain data that's populated by streams. So actually I need to clear both of these. So let's get those, head back down to where we're working. And then we would take both of these and just say dot clear. Unlike the Xbox gamepad buffers, these are extensible. We allow for any arbitrary number of stream IDs. You just pick one for whatever player you want. If you want, you can make a stream ID represent a not player, like a AI, or you could use it for the sake of identifying like party game input, like if you were on like Super Smash Bros, for example, and you say press A to join, you can identify which gamepad pressed with a null or a reserved stream ID. So yeah, it gets complicated, but I need to clear these instead of just setting them as unused. Stream bindings. Okay, I think that's probably it for now. Stream bindings, stream blocked. This low level stuff gets reinitialized. So the mouse access accumulator, the mouse delta accumulator, this is all like raw, low level raw value stuff. That actually gets set to, oh, hang on. No, those values are allowed to persist. That's fine. Okay, and this is the context registry, context stack. I don't think we're flashing input contexts. I think that we've been depending on like game systems and game states to clear out their own input contexts, and that's bad form. Okay. So new plan. I'm going to click right above all of this state, shift click and select it all, and control C it. And I'm just gonna straight up take all of the state, and being careful to double check that I don't have any extraneous state between these methods. I don't think I would, but yeah. And heading back down to this cleanup code, we're just going to go through every single one and reset what's necessary. So we already did the KBM buffer dot is assigned. KBM buffer dot. So there's these other values as well. Axes, block status is assigned. These all need to be reset. So just reviewing what types these are. The axes are it's a multi-dimensional array of floats. This is a single-dimensional array of bools. This is just a bool. This is a multi-dimensional uint64t array. Single-dimensional uint64t. And this is a constant, static constant expression line, enterprise input, KBM, number of mouse axes. Yeah, so that's fine. So actually what I can do on this, instead of saying is dot is assigned and setting everything individually, I can just do a mem0 or zero mem? Is it zero memory or is it mem clear? I thought it was mem0 off the top of my head, but I guess not. Or memset, that's what it is. We just memset it. So we'll be doing KBM buffer. So that's the thing we're doing. We will be replacing it with 0, and we'll be doing it for size of KBM buffer. Oops. Except for I need to give it the address of KBM buffer. Cool. So this is just a quick C way of zeroing out the memory. Everything in here, this is a plain old data struct. So if we go into actually the definition of a KBM mouse buffer, we have a constant here representing the number of IDs there are. So that's just an informational constant. But this is just a bool, 64-bit ints, floats, and so on, and all of the array sizes are also known at their compile time array, so they're actually in global memory, or not global memory, in the structs memory. So we can just do memset and it'll zero all of that stuff out. Now in the case of the gamepad buffers, so let's close that up. We'll just keep going through the list of the things I copied. So there's a vector2 for input cursor pause. The current cursor position is reset whenever you move the mouse around anyway, so I don't need to clear that value. Then there's input gamepad buffer. That's this stuff here. What I was doing before was I was just clearing the assigned stream, but let me confirm my earlier presumption that I am pre-allocating those, because I think I am, but maybe I'm not. So we got bind controller, we specify a gamepad ID in the stream. If the controller is less than size plus 2, size plus 2 because 0 is null and 1 is the keyboard and mouse. then we will have an assertion failure. Attempted to assign an unallocated controller ID. An unallocated controller ID. So there must be. So apparently I had another system initialize the controller IDs. So where do I do that? Let's keep looking for use cases of GB buffer. Okay, here we go. Check for controller wake. Okay, so this is only for controllers that have been quote-unquote allocated. Allocated may not be the right word to use. Okay, so I don't think it's even handled in this code. It's got to be handled in the platform. Okay, here we go. Get raw input. So this is the X input API stuff. So we actually pull X input to get the first 4 gamepads. X input to gamepad ID. That's interesting. Okay, so on the Windows side, we have a structure that's checking whether the gamepad ID is active. And that's extensible. Okay, here we go. I think I found it. So X input to gamepad ID at I, because there's always 4 Xbox controllers. That's the way that the API works. It was designed around the Xbox 360, which you can only connect 4 controllers at once. We set its gamepad ID to is gamepad ID active.size, and then we push back and then place back the okay. All right, so we're getting somewhere. So the gamepad ID is allocated. It does get memory allocated for it when we invoke get raw input, which I believe is done every frame. And when you have interacted with an X input controller for the first time, or at least when the packet number changes. So I'm not sure if that means that it's the first time you connect a controller, the packet number changes. That probably is the case, or the first time you connect it. But this is not happening for every controller every time. It is getting a little confusing. So that would mean what does that mean for input cleanup? Well, the short of it is that the gamepad buffer, to bring the gamepad buffers to a system start situation, we would need to clear out the vector, to actually go in and say .clear. But I'm wondering whether we want that to persist or not into a reload. So let's find out which situations we use get raw input. Get raw input is invoked in input update. So first thing we do is we zero out all of the input blocking flags. Actually, this code here is probably useful for what we're doing in cleanup, but I'll come back to that. We zero out the blocking flags. We accumulate raw mouse deltas. So the accumulation is required for the sake of splitting up fixed time and dynamic time. That's outside of the scope of what I'm doing right now to talk about that though. Reset active context axes. Right, so we're taking each of the axes. We're in each of the contexts. We are setting them back to 0 because we want them to be incremented by the input this frame. And then we use get raw input. Okay, so this is the only place where that's invoked in get raw input. Okay, so I think we're safe. I think what I can do is I can just clear that out. The code is currently set up on the platform specific side to handle expanding the allocated controllers when a controller that doesn't already have a buffer is invoked or is like turned on and used. So back in the input side, or the input dot cleanup side here, we can do instead of going through all this code, we would just say tp buffer dot clear, and that should be enough. Good. Man, this is this is complicated. There's a boolean for current buffer set equal to 0. I'm not going to change that either, I don't think. No, I don't think so. This is marking which, whether we are in the front or the back buffer. We keep track of both the previous and the current state of all of the controls, so that way we can identify when they've changed. So, for example, if during the last frame you've pressed down the trigger 0.4, like 40% of the way, and then the following frame it's pressed 60%. We want that to trigger events that have a threshold of 50%. So we do that by comparing the old and the new value. And I use a boolean because it's 0 or 1. I actually use it as an integer to the first dimension of the raw buffer arrays. That can probably be the same as what was before. And you know what? I might be overthinking this with the keyboard buffer and the gamepad buffer, because we care about clearing the block statuses, and we care about clearing whether they're assigned. Well, we care about whether the key is assigned, but I don't think we actually care about the block statuses, the axes, or the keys themselves. And I say that because during input update, down here, we actually clear them every frame anyway. They're used to identify as you go through the stack, or go through the context stack, whether or not a control is still available for use. Yeah, and actually the same thing was true for the gamepads. So what I had before was probably best. KVM buffer is assigned to 0. Sorry, it's false. And then KVM buffer dot anything else. Axes block status. All of that stuff should be allowed to persist in the editor application, because we can just continue to update those every frame. Okay. Man, this was hard to wrap my mind around. So actually what we had before for the gamepad buffer is actually probably fine as well, because the controllers are not being disconnected and reconnected during reload of the game. They're only being reassigned. So we'll do what we did before, actually. I'll do a range-based for loop on this one. And so we'll do gamepad dot assigned stream equals stream ID 0. But to capitalize the D on that one? Yeah. Okay. Oh, and that's not a constant reference, just a regular reference. Okay, cool. Let me just do add buffer, explicit type there. Okay. All right, making progress. We'll come back to stream bindings and is stream blocked. On to the next thing, input context registry. That does need to be cleared. So I'm gonna take a look at that. Context registry dot clear. This is a lot more straightforward. Basically, it's just a map for the hash name of a context to the context itself. So when you go to load a input INI file, all of its named contexts are looked up from this table. So what this means is that when you go to reload the game, it'll just have to this will all be reloaded by the INI file. And it's important that we actually clear it here, because if we make changes to the game code that would rename the context, so we rename what the context is supposed to be, and we also change the data file to reflect that new name, we don't want to keep around the old copy with the old name. We want that to be gone. Context registry.clear. And then there's the context stack, which similarly context stack.clear. Actually, that's a list now. Oh, but it's also, hang on, I'm trying to remember how this works. So it's an std list of contexts is what that is, but it's also, so it's a C array of lists. So there's up to 10 layers, which is something that we can configure later down the road. So what I actually need to do is I need to go through and clear each and every one. Okay, so do context for is less than max context layers plus, and we go through context stack at I dot clear to clear the list. Okay. Next thing, input layer of context. So there's a map for each context handle telling us which layer in the context stack it belongs to. So yeah, we just clear that. Because we're reloading all of the contexts. even the editors, assuming that the editor has them. Cool. And then we got std map of what? This is a big long looking one. Action callbacks. That's a fun one. So this is a really complicated looking templated type. It's a map associating a void pointer, which is a pointer to what is this again? If I can parse this out, it might be more clearly explained in the header. Here, let's go to the header. Wait, this is not a header item. Okay, so we can do this. So it's a map of void pointers to another map of hash names to a vector of pairs, the pair containing a function pointer and an std weak pointer to a state. So so this is the callback. It's a std function. It takes no parameters and returns void. This is the state that was active when the action callback was registered. You can have a number of them associated with the context name itself. So context can have multiple action mappings. And all of those are associated with a void pointer. And I don't remember off the top of my head what that is for. So let's go to its use cases. We are using... Oh, right, okay. We are using the address of the context itself, the context instance, to look up. Okay, that makes sense. Okay, so that's a big, long, complicated thing, but it was just kind of like how I needed it implemented at the time. So this is the instance of the input context. That gets you a way to look up the bound context name and all of the associated pointers to functions that come with that. Yeah, so this is all context, instanced context information that all needs to go. So we'll take action callbacks dot clear. huge number of, yeah. So calling clear on it should call the destructor on the map and on the maps inside and on the vectors therein and on all the pairs therein. So that should be entirely fine and good and just good. And then we have input access values. Okay, so this is the actual axes values that we use for the mapping process. So this would be a pointer to the context, or the address of the context. This would be the map between the axis name and its value. So these are converted processed values. We need to flush that because the names of the so all of the context instances and all of the names of its associated axes are all going to be cleared as well. So we'll do axis values clear. Right. Oh, but there's two of them. So we'll do 0 clear and then 1 clear. And there's two because we need the before and after. So the previous frame and the current frame, we need to store their values. Cool. So those are all empty. Now we are down to mouse axis accumulators. These are raw, low-level stuff, so that's fine to keep. The accumulators will be flushed every frame anyway. I'm like 90% sure, but let me double check. is fixed update pending. Yeah, so it gets zeroed out every time. So we're good. Here. Here we are. Clean up. So that's going to be taken care of all on its own. Stream bindings and is stream blocked, and that's the stuff we were dealing with up here. Stream bindings, associating a... So index by stream ID, so it... Right, so stream IDs... Alright, so I'm kind of remembering now. So if you add a stream binding for stream 3, what happens is it inserts all of the null controller IDs, controller ID 0, for all of the intermediate stream IDs. So this is indexed by stream ID. That needs to go, so we're clearing it. And then same thing for is stream blocked. That's blocking state information for streams, and we will have none of it. Okay, that was a lot. That's why we go through all of this trouble to verify your code that you put in your source tree, because sometimes you'll overlook something big like this. Let me F7 that, and I'll quickly make sure that everything is still working. That's taking some time, isn't it? Technically, the code that we modified affects every build target, so that probably is why it's taking so long. It was rebuilding 41 different items. Okay, so it's loading. I click the X button. It doesn't crash, so that's good. Let's switch to the launcher application. Run it. Got test state, able to move the controls around, able to quit. And clean up, doesn't break anything. I guess the real test will come later when we go to try to hot reload the code, but for now this is good for committing. So we'll come back to committing this without this, because what I'll do is I'll just cut this out and then save it and then commit and then come back and paste it back in. Not very elegant, but that's what I gotta do for this one. Okay, close out of that. Going back to the unstaged changes. This is the what happened here? Oh, I deleted a tab. One of the things I'm going to be needing to do soon is actually like implement Clang Clang Tidy and actually like get some automated formatting going on to catch all of these little typo mistakes. But I'm not going to commit a tab formatting fix here. In input.h, we now have input cleanup, which needs to go in this header, so this is going to be staged. Scene-manager.h. Scene-manager.h needs to be it needs to friend the unload game module method, because an unload game module will invoke cleanup. But you know what? I'm not sure how I feel about that. Let's review unload game module real quick. So this is where we actually take and we first we clear out all of the function pointers for the game module's entry points. So the game system init, game init, and then play an editor init. And then we actually call free library on the game module handle as well. We also clear So we actually clear out all of the changes to the file paths. That is, we reset the data.dir path to the editor data.dir path, which is wherever, which will be conditionalized depending on whether you're sandboxed or not. I'm wondering whether this should be handled elsewhere. The problem is that I just don't know that it should be. The file system. So, I mean, to back up for a moment, this method is only ever called on the editor and the launcher. It's not ever called on a shipping game. Because the shipping game is statically linked and the game module, all of its stuff is statically linked and then subject to link time optimization. So if we go to unload and reload the game module, basically we just invoke this and then we invoke this big long YAML file parsing thing, where we get the project file path and we reload the game from it. And I guess when we go to load, yeah, okay, I'm gonna leave it. I'm gonna leave the file path changing code in there, because when we go to load the game module, that's when we actually load the YAML file for the project, and parse out the information about the directories and stuff. In the future, I might come back and move that off into the file system somewhere, but for now that's fine. So back here, unload game module was a friend for the sake of what? I actually don't see the benefit. Scene manager, okay, I think I know what it was. Probably what I had was that scene manager cleanup. Let me build and confirm. I think what we did was originally we were going to have the cleanup methods be called by the unload module section, but now we are just having those invoked by the destruction of the engine runtime. So we don't need to have that friend reference anymore. I think I need a faster PC. This is like a 7-year-old computer at this point. And this shouldn't take this long. Okay, everything seems to be compiling and working correctly. Yeah, I'm able to launch and run and do stuff. Alright, so that can go. The cleanup method, though, is still in use. If we go to runtime.cpp for the engine, we should have scene manager cleanup, which wasn't there before. Cool. So that's good. Save that. And then I don't need game module load in the header anymore either, because we're not friending it the game module load function anymore. Perfect. So that should be good. Scene manager.h. And then state manager.h is the next one. Compiling and working at the same time, but that should finish in a minute. Enterprise, runtime, game module load. Okay, it looks like the same thing here, but the one exception being that the cleanup method already existed, so I can get rid of all that. Then build and make sure that it didn't break something. Which I probably didn't, so I'll move on while it's compiling. That's a little confusing. I just undid the change, and then I come back to changes, and it's indicating that the change was committed, but it wasn't, because I identified it using a git diff. Wait for compilation to finish before I look back at that. Runtime.cpp, what do we need to change there? Anything at all? No, that seems to be clear cut and good to me. Yeah, we'll stage that. And I must have accidentally staged the file with changes and undid them. Because now that I committed that change, or staged that change, it's not showing up in the staged changes lists. It just disappeared, so. Good. Good. Nearly done. Oh, hang on. Is that a thing? Can you do that? Can I take and cut this out and save, and then stage that, and then undo and save, and then... Oh, you can. I didn't know you could do that. That makes things a lot easier. So I can actually keep the thing that I can stage only the differences. That's interesting. All right, cool. So I've staged everything in input.cpp except for the one bug fix, which I wanted to make it explicitly its own commit in case I need to refer to it later. Cool. Scene manager. Added a couple of asserts that I probably should have had to begin with. And then I added a cleanup for scene manager where we clear all of the callbacks, all of the serialization functions for new component types, and we empty out the scene pool. So all of the entities are cleared out and all of their components are cleared out. Okay, so this is good to commit. And time.cpp. Where the only difference is that we initialize current timescale to 1 down below. Because we do that, because we initialize it down below, I'm thinking that it might be wise to remove the initialization up here so we're not double initializing it. You know what? I'm fine with the double initialization in this case. Timescale always means a multiplier to time, so 1 is a 1 will always be the default value. I'm never going to need to tweak that. It's going to be the unity value, so I'll leave that there. Add that change. Okay. Dang. All of that stuff that we had to just proofread and bug fix and everything. So all of the files that I just added are all in service of being able to reload correctly. However, we still have editor code to go over. So I'm going to need to look at that now. Let's take a look at the launcher real quick. Okay, the launcher had a very important change in its CMake lists as well, but that's to fix a different problem, so I'm going to leave it out of this commit. The editor, we added a couple of files to the CMake file. We added the native file dialog. We added dependency linking to native file dialog. And we fixed the VS command arguments. Actually, this is fixing the same problem as the launcher had, but put that on the back burner for the moment. The sorts of changes that we would be seeing in the editor, to review this real quick, all pertain to adding the functionality to reload the game module, or to basically to add the open and close project options. So I think I'm going to leave everything from the editor out of this commit. Except for the runtime stuff, because the editor's runtime now deletes and recreates the engine runtime. So I need to, I need to commit this code, I think. So now instead of going to scene editor init and window init and stuff directly, we do that in the runtime. Right? Window editor, create primary. We move that up here. Okay. Oh, in addition, this code is doing the default loading of a game project. Actually, none of this code needs to be committed. It'll work just fine with the old build of the editor. Okay, we have a set title. Yeah, we don't need that. Okay, and this was just implementing the open, scene, and close project. Or sorry, the open project and close project. This would be being implemented here, and that's fine. And this is just implementing the open dialog. Okay, so we can safely skip over committing anything from the editor code and the launcher code, and I'm pretty sure the test game code. Yeah. Yeah, we can. Cool. And we can even skip adding the native file dialog. Okay, finally got. All right. Engine runtime can now be destroyed and recreated. Runtime Destructor cleans up all systems in preparation for hot reload. Good. This bit about is game module loaded. I don't think that's part of this actually. I'll just throw it in this commit. Nobody's proofreading my work but me. Okay. And we'll say we added project-friendly name parsing to load game module. Cool. Confirming that there's not any other important notes. We did move to retaining the reference for the global VAL, but that's not actually used for anything yet, so I'm not going to comment on it. It was only retained for the sake of destroying the thing. Good. Good. Available entity pool indices outside. Strictly speaking, these aren't part of what I did, but I'm not gonna bother making them a separate commit. Okay, cool. Good. Gosh, that was difficult. Okay, so now where does that leave everything else? There's a couple of bug fixes I need to fix. In particular, I want to commit these changes to the CMake lists because I had forgotten to update them to reflect the new sandbox and the new project specification command line options, which means that out of the box, things will break on a fresh clone of this. So let me get rid of those. I'll save and stage, and then undo, and then save again. So the two added state, teststate.h and teststate.cpp, those are all still included in the project. But the fix to the command line arguments is in place. Okay, here we go. And the launcher application, I need to commit that that's that CMake file as well. Okay. And the editor CMake list file has the same problem. Well, actually, it's got a slightly different problem. It tries to escape the quotes, and apparently that breaks debugging in some situations. I'm not really clear on why, but for some reason, like Visual Studio has an issue if you do a quote in your command line arguments. So I just take it out. Let me exclusively commit those changes. Oh, can I just do a plus sign and stage just the line? Oh no, I can't. Okay, that would have been really sweet if I could have just done like staging. Oh, I can. Hang on. There's an option that says stage selected ranges. Ha. Okay, I for the longest time I didn't know that you could do that. So I can just like right click on a selected text range and commit or stage that thing for committing, but not the other way around. I know that on Xcode there's an option for you to select each individual line and commit just those, but I didn't know that VS Code could do it. Cool. That needs to be uncommitted. Cool, perfect. So now we've got the fixes for the command line options for the editor, launcher, and the test game. Let's add those. Fixed. There we go. Fixed debug arguments for VS Xcode. Like that. Perhaps after I've gotten all this stuff committed, the next thing to look at would be to get Clang Tidy set up finally. Just to fix the legibility issues across the whole project and prevent them from creeping up on me. Okay. I'm probably in a position where I can commit the file open and file close options on the editor, but I'm gonna be doing that later because I've been streaming for 3 hours and I'm ready to take a break. But I think that before I commit all this stuff, I'll be adding Clayton Tidy probably. It's about time. But yeah, but let's not forget about this very important bug fix. Fixed crashing when quitting via gamepad action. That's a good summary. Cool. Cool. The rest of this is gonna stay. But yeah, it's a much cleaner looking commit tree for sure. Let me go ahead and, or a commit tree, source control tree for sure. I'm going to go ahead and sync these, push these up to the cloud, so it'll be on GitHub. I think that's where I'm going to leave the stream today. Didn't actually get around to the editor stuff. Turned out that there was a number of bugs that we needed to quash first. But now that that's all done and we've got that all committed, the way is kind of clear for actually doing cool stuff with the loaded projects in the editor. Just gonna quickly recompile and make sure I didn't break something and forget about it. There we go. Editor is going. We can go close project. If we go to debug console, we see that it's unloaded the DLL. Open project. We can select the testgame.db project file, and it automatically loads it and calls GameSys on it, and we can rinse and repeat. Close project. Unloads, and open project. Cool. And I'll need to do something about the menu because presently, if I go, there's a problem with this implementation in that if I go to open project, that this dialog locks this window, but not its window response messages. So if I try to do something like that, resizing is supposed to trigger redrawing code, but I'm still in the middle of drawing the IMGUI panel. But yeah, that's going to be fixed by I'll probably switch to using native file edit view menus instead of doing the IMGUI version. But yeah, we'll come back to that. Thanks for anybody who stopped in. I'll go ahead and post this one on YouTube as well. Bye and stuff.